This begins the component deep dives, and we start with the information every agent receives at each step: context. I'm Mehrdad, and here's the claim I want to establish up front. A bigger context window does not fix a context problem. It usually hides the failure. It gives stale state, repeated instructions, and irrelevant output more room to accumulate around the useful signal. Today, we'll examine what degrades, what overcompression destroys, and how the harness keeps context useful for the next decision. The common reflex is understandable when an agent forgets an instruction, loses an earlier fact, or becomes inconsistent halfway through a task. We respond by giving it a bigger window, assuming that more capacity will solve the problem. But capacity may not be the constraint, because the model still has to find and apply the right information. Attention is the real constraint. As the window fills, useful evidence competes with stale observations, repeated instructions, and tool output for influence over the next decision. Before increasing the limit, inspect what the model must attend to and remove material that no longer earns its place. I find it more useful to treat context as a playbook you grow, rather than a window you continually refill. A good playbook stays compact, current, and specific to the decisions ahead of the agent. It preserves constraints, evidence, and lessons that still matter while removing repetition and expired state. Context management is not about fitting everything beneath a token limit. It is about maintaining the smallest high-signal set that still supports the task without discarding necessary detail. Instead of asking what else can fit, ask what will genuinely help the next step. Chroma's context rod experiments make the length problem visible across a broad range of frontier models. Performance degraded in every model as the input grew, although the pattern and severity varied by task. Early in the window, relevant signals are easier to recover, creating what this slide calls the smart zone. As more material enters, recall becomes less reliable and the model moves toward the dumb zone. This degradation is not a cliff waiting at the advertised limit. It is a gradient that begins much earlier. A window can have plenty of space remaining while already providing a poor working context. Instead of asking whether space remains, ask whether the model can still recover and apply the right evidence. Length is only one part of the mechanism because an item's position inside the context also affects recall. The lost in the middle result shows that models often recover information near the beginning or end more reliably. Place the same information in the middle and recall gets worse even though the underlying fact has not changed. This is why inclusion alone is not enough. An important constraint can be present in the window and still fail to influence the answer. Keep stable instructions clear, bring current evidence close to the decision, and avoid burying critical state inside a long transcript. We can now name two opposite failures that appear when context management moves too far in either direction. Context rot comes from overfilling, as length, noise, and stale material gradually dilute the useful signal. Context collapse comes from overcompressing, especially when a model repeatedly rewrites its own working context. Brevity bias makes each new version shorter and more generic, quietly removing details that later decisions may require. The Agentic context engineering research documented an extreme case where a rich context collapsed to almost nothing in one rewrite. Heaping everything produces rot, while compressing too aggressively destroys detail. Good management preserves what future decisions need, at the resolution those decisions require. Agentic context engineering addresses that tension with an incremental loop built around three actions: generate, reflect, and curate. Generate means doing the work and capturing the resulting trajectory, including evidence, choices, and outcomes. Reflect means identifying which decisions, useful signals, and errors actually affected the result. Curate means merging those lessons into the playbook as small, structured updates instead of rewriting everything. That distinction matters because a full rewrite invites detail loss, while a bounded update remains inspectable and preserves material that did not change. In the experiments, this approach improved agent results while reducing adaptation latency. The broader lesson is to update context deliberately in small units with a clear reason for every change. In production, I use 4 practical levers to protect a finite context window. First, compaction replaces older detail with a faithful summary that preserves decisions, constraints, and unresolved work. Second, just-in-time context keeps references lightweight and retrieves source material only when the current step needs it. Third, structured notes move durable facts and decisions into an external store with explicit, inspectable fields. Fourth, sub-agent isolation gives a bounded subtask its own clean window, then returns only the result in supporting evidence. This isolation is one reason multiple agents can help, even when every agent uses the same model. Anthropic connects these levers through one useful idea: context is an attention budget. Spend that budget on the smallest high signal set that supports the next action. The model reads the context it receives, but it does not manage the life cycle of that context. It cannot reliably decide what should enter, what has expired, or what must remain verbatim for later use. It also cannot determine which durable facts should move into external state instead of occupying the active window. Those decisions belong to the harness. Think of context as a managed resource, similar to memory in an operating system. The harness allocates the window, retrieves into it, compacts older material, isolates workloads, and records durable state outside it. Context construction is not a one-time prompt setup. It is an active control loop surrounding every model call. Carry 3 takeaways forward. First, bigger is not automatically better because context quality degrades with length and position changes what the model can recover. Second, context has 2 opposite traps. Overfilling produces rot, while overcompressing risks collapse and the loss of necessary detail. Third, curate instead of refill by maintaining an evolving playbook through small, deliberate updates. Compaction, just-in-time retrieval, structured notes, and sub-agent isolation work together to protect the model's limited attention budget. That is context management. The harness protects the model's attention by deliberately curating what it sees. If this series is useful, subscribe to Multi-Agent Academy, and you can also connect with me on LinkedIn. Next is Video 9 on agent memory, where we'll examine what should survive across sessions. We will also see why adding a vector database is not the same as giving an agent memory. I'll see you there.